Next is question number 76, which says that points A and B divide the line segment joining the points 1, 5, 3 and -2, 3, 4 in the ratio 3:4 internally and externally respectively. Then the coordinates of the midpoint of A and B are. So here we have to find firstly the coordinates of point A and B, right? So let us say this is the line segment. Let us say this point is P and this point is Q, right? So let us mark them here. P, that is 1, 5, 3, and this is Q, that is -2, 3, 4. Now the point A is dividing them in the ratio 3:4 internally. So we can write the coordinates of A as 3 into -2, that is -6, plus 4 into 1, that is 4, upon 3 plus 4, that is 7. Similarly, we can write the y coordinate as 3 into 3, that is 9, plus 4 into 5, that is 20 upon 7. Similarly, the third coordinate is 4 into 3, that is 12, plus 4 into 3, that is again 12. So this is 24 upon 7. So the coordinate A can be written as -2 by 7, 29 by 7, 24 by 7. Similarly, it is given that the coordinate B is dividing the line segment in the ratio 3:4 externally. So the coordinate of B will be 3 into -2 minus 4 into 1 upon 3 minus 4, that is -1. Again 3 into 3, that is 9, minus 5 into 4, that is 20 upon 3 minus 4, that is -1, and the Z coordinate is 12 minus 12 upon -1, right? So the B coordinate can be written as -10 upon -1, that is 10, 20 minus 9, that is 11, 0, right? So this is the B coordinate. Now we have to find the coordinates of the midpoint of A and B. So the coordinates of midpoint, let us say T, is -2 by 7 plus 10 upon 2, 29 by 7 plus 11 upon 2, and the third one will be 24 by 7 plus 0 upon 2, that is 12 by 7, right? Now we can see that 12 by 7 is given in 3 options, so we have to find the x and y coordinate also. Now here, multiplying and dividing by 7, we will get 70 minus 2, that is 68 upon 14, 77 plus 29, that is 106 upon 14, 12 by 7. So this can be written as 34 upon 7, 53 upon 7, 12 upon 7. That is given in option number 1. So the correct answer is option number 1. Next is question number 77, which says that limit x tending to 0, 2 times sine square x by 2 into 1 plus cos x upon x square into cos square x whole raised to the power 1 by 2 is. Now we know the value of 1 plus cos x will be equal to 2 into cos square x by 2. So putting this value there, we will get limit of x tending to 0, 2 times sine square x by 2 into 2 times cos square x by 2 upon x square cos square x raised to the power 1 by 2. Now here this can be written as 4 times sine square x by 2 into cos square x by 2, that is, it is equal to sine square x, right? So this can be written as limit x tending to 0, sine square x upon x square cos square x whole raised to the power 1 by 2. Now this can simply be written as limit x tending to 0, tan square x upon x square raised to the power 1 by 2. That is, it is equal to limit x tending to 0, modulus of tan x upon x, right? Now we know that from the left hand side and right hand side both, this limit is equal to 1, right? So the correct answer is option number 3. Next is question number 78, which says that let z belongs to complex number c and if P is equal to Z, that is argument of Z equal to pi by 4, and Q is equal to Z, that is argument of Z minus 3 iota equal to 2 pi by 3, then number of elements in P intersection Q is equal to, let us draw coordinate axis. This is x and this is y axis. So we can plot the points P as argument of Z equal to pi by 4, right? These are the points P which are lying on this line. Similarly, we will draw Q. Let us say this point is 3, 3, right? This is lying on this line x equal to y. This point is 3, 3. So these are the points Q, right? Where this line when joined here makes an angle of 2 pi by 3 with positive x-axis, right? But this point is not included here. Only these points are included here, right? Similarly, for P, these points are included. Now, if we see that in the intersection point, we have not even one point, right? So, the number of elements in P intersection Q is 0. That is, correct answer is option number 1. Next is question number 79, which says that if fx is equal to greatest integer of sine square x minus e raised to the power x plus 2 times ln of x plus 2 minus 3, then the value of f dash 0 is. See, if we talk about this question, the values of fx will always be integer values, right? So the graph is, let us say, anything like this. So the value of f dash x will either be 0 or it will be non-existent, right? For example, if I take these points, so here f dash x is 0, right? That is, slope is 0 at this point. But if I talk about this point, then on the left hand side and right hand side, values are different. So f dash x does not exist at these points. So now we just have to check the value of f of 0 and f of 0 plus and f of 0 minus, right? And here in this question we can see that f of 0 is equal to f of 0 plus is equal to f of 0 minus, right? These three values are equal, so we can say that the point is lying somewhere like this. Hence we can say that the value of f dash 0 will be equal to 0, right? So the correct answer is option number 3. Next is question number 80, which says that if z plus z inverse is equal to 1, then z raised to the power 2018 plus z raised to the power minus 2018 is equal to, where iota is equal to root of minus 1 and z is a complex number. So in the question it is given that z plus 1 by z is equal to 1. So if I multiply the equation by z, we will get z square minus z plus 1 is equal to 0. That is, z is equal to 1 plus minus under root d, that is 1 minus 4, that is minus 3 upon 2. So this is equal to 1 plus minus root 3 iota upon 2. Now this can be written as minus omega or minus omega square, right? So these are the two values of z. Now if I take z equal to minus omega, in that case, the value of z raised to the power 2018 plus 1 upon z raised to the power 2018 is equal to omega raised to the power 2018 plus 1 upon omega raised to the power 2018. Let us write it as, in the multiple of 3, it can be written as 3 into 672 into omega square plus, similarly, 1 upon omega raised to the power 3 into 672 into omega square. Now, multiple of 3 in the power of omega is always 1. So, this can be written as omega square plus 1 upon omega square, which can be written as omega square plus omega, which is equal to minus 1. Right? That is given in option number 3. But in the other case also, let us find what is the value that we obtain when z is equal to minus omega square. That is, it can be written as omega raised to the power 4036 plus 1 upon omega raised to the power 4036. Now again, converting it into multiple of 3, we can write 4036 equal to 3 times plus 1, right? So this can be written as directly omega plus 1 by omega, that is equal to omega plus omega squared, that is again equal to minus 1. So from both the cases we get the required value as minus 1. So the correct answer is option number 3.